Hello guys, welcome back. Today we are going to learn about Black-Scholes method model in Python. Today we are going to learn how this option pricing and option Greeks can be done through Black-Scholes model in Python. As we know, Black-Scholes method model is widely used in these financial industries to calculate the option price of both call and put option, as well as to calculate the option Greeks of these Greeks through Black-Scholes method model. I'm going to tell you how to do all these mathematical equation of this option price as well as option Greeks through Python. So please stay tuned throughout this video to get to know a lot about Python programming and to know how to calculate this option price and option Greeks. So before that, in this Black-Scholes or BSM model, there are some assumptions. We are saying if there is a market of exists which is consists of European option and which all the option can be exercised at the expiry, and the return of the underlying asset are normally distributed, and the risk-free rate and volatilities of the underlying asset are constant, and there is no dividend and transaction cost, then we can calculate the price of the option through this mathematical equation. So let's go and learn how we can do all this mathematical equation in Python. Before we start, let me explain a little bit about option pricing. The option pricing is basically divided into two parts, which is intrinsic value and time value. The intrinsic value is basically difference between the spot price and strike price, and the time value is mostly depend upon the time to expiry, volatility, and rate of interest. So, if I will tell you that if there is any changes in these 5 parameter, then of course this option price will change. So that is my Greeks. It means that if my spot price will change, then my option price will change. That is called your delta. If the time to expiry will change, the option price will change. That is called your theta. If the volatility will change, then the option price will, of course, it will change. Then we call it as vega. And if the option price will change due to change in rate of interest, then we call it as rho. So any changes of these 5 parameter will of course affect this option price. Alright, so we are going to learn all these option Greeks, as I told you, delta, gamma, vega, theta, and rho. So we are going to see how we can do all these mathematical derivatives and mathematical equation through Python. So I have write down some of the points here for each Greeks. You can go through all these and we can quickly start about all these things. So in this Black-Scholes method model, so we can assume some of the points which I already explained. In fact, let's quickly start about this option price first, and then we can go to option Greeks. So as you can see in this mathematical equation, there are some of the variables are there. So let me tell you what are the variables. So C stands for call option price, put is put option price, S is for spot price of the underlying, K is the strike price of the underlying, R is risk-free rate of interest, time is time to expiry, sigma is your implied volatility, or you can simply say standard deviation, and N is your cumulative distribution function of standard normal distribution, and N dash is your probability density function of standard normal distribution, and D1, D2 is the probabilities of option will expire in the money, and E is the exponential function, and ln is the natural log function. So these are the things that we are going to use in this mathematical equation. All right. So let's quickly start and see what we can quickly start and see all these mathematical equation, and we can quickly learn how to do all this mathematical equation and how to calculate this option price and option Greeks through this Black-Scholes model in Python. All right. So first, let's write down all the variables. So variables, let me put it as small one. So variables are, so what are the variables we can write down here? Just simply copy it and paste it here. So we are going to calculate the call option price. I'm going to delete it. So put option price, I'm going to delete it. So spot price of the underlying, strike price of the underlying, risk-free rate of interest, time to expiry, implied volatility, and all these we are going to calculate. Okay, so N and D1, D2 and E, all this. Okay, so before that, let me go to one of the exchanges in India, which is NSE, National Stock Exchange. This is a stock exchange in India, is very famous here. So this is the option chain. If you don't know what is option chain, is basically you will get to know the price of all the option of different strike. So what I'm going to do, instead of putting arbitrary value here, I'm going to take all the inputs from here, so that when we are going, once we calculated the value of option price, we can compare with this whether it's matching or not. If it's matching, that means all the mathematical equation what we have done through Python is correct. You understand? So let me talk about here. So this is one of the underlying asset I'm talking about. This is Nifty. It's an index. So here if you see this Nifty index is today, this is my spot price. So I can see 17,854.05. So that is my spot price. I can just say this is a spot. All right. And strike price, I can take one of the strike price here. Here you can see there are a lot of strike prices are there. So if you see the 17,850 is the ATM at the money option, and here all the in the money option, this is out of the money option. So this is basically a typical option chain, and we are going to calculate, let's say take an example, 17,750. So 17,750 is the strike price for us, 17,750. And rate of interest, here if you see, they are using 10% interest rate is applied while computing implied volatility. So we are going to use the same 10% here. So this 0.10, or you can say 0.10. Time. So the time is, so basically this underlying asset Nifty index is expiry, weekly expiry. So this is a Friday calculation. So till Friday this value is there. 3rd of February is on the Friday. So 9th of February is the expiry, you can see here. So 6 days to expiry. So 6 divided by 365. So 6 divided by 365 is the time. And sigma is standard deviation. So if you see here, so for different strike there are different IVs, and this side is call, this side is put. So if you say 17,750 is the strike price, and the IV or implied volatility that they are using is 8.39, and if you are using a put option, you can take this implied volatility. So the implied volatility or the IV is different from the historical volatility. So whatever the volatility or IV they are using, we are going to use the same to understand whether the calculation is right or wrong. Okay. So here if you see, we are going to calculate the call option price. So first, so we are going to use this 8.39 is the IV. So I'm going to put 8.39. So this 8.39, if you put that, so 0.0839. All right. So we got all the variable. S is the spot price, K is the strike, R is the risk-free rate of interest, T is the time to expiry, and sigma is my volatility. If I got all these, then I can calculate the call option price and I can calculate the put option price, and then I can see what is the option price, call option price here. 17,750 for call option price is 160 and the put option price is 81. If we can calculate that, that means that we are calculating correctly. Okay, so as we know, first we have to import two libraries. So let's put import libraries. So one is import numpy as np, and then import, so from scipy import stats edge so from scipy dot stats, I think there is stats inbuilt that, so yeah, scipy dot stats import norm. All right, let's do that. So these two libraries we need. So let's do one by one. So first of all, let's see the mathematical equation of call price. This is put price. So the call price is S0 ND1 minus K e to the power RT into ND2, and put price is K e to the power minus RT into N minus D2 minus A0 ND1. So let's do that, and D1 D2 is here. So if you first we have to calculate D1, then we can calculate D2, then we can see the price of call, and then we can calculate the price of put. So what is the D1 D2? So let's write it down the formula here to make it easy. Okay, so this ln h0 by k plus r plus sigma square by 2 into t. So np dot log, this is your ln, S0 is S is basically your strike price. Okay, S0 divided by K. Okay, I got this one, and then I will say plus R is R for us, risk free rate of interest, plus sigma square. Sigma square is sigma double star 2, that is sigma square, divided by 2. So we got this. All right, now once we do that, that multiplied with t. Okay, so that whole divided by, so that whole divided by sigma multiply with np dot square root of t. Okay, so this is your D1. Okay, let's recheck again. So np dot log s by k plus r plus sigma square by 2 into t divided by sigma sigma into np square root of t. So this is your D1. So let's put it here. So D1 is equal to this. Let's see the D1. So D1 is equal to, let's see the D1. So D1 is 0.7015. Okay. So I got the D1 now. So I will see the D2. So the D2 is, let me delete this, I don't need this. So let's see the D2. So D1 minus sigma square root of 2. So D2 is equal to D1 minus sigma into NP dot square root of T. So this is the put it whole. So if you see that, so my D2 is coming this one. So I got D1, I got D2. So now what I will do, I will just calculate my call price. Okay. So this is my D1, D2. So I will see what is my call price. So let's see the call price here. I'm just inserting one line here. So what is the call price? Call price is S0 S into ND1. So ND1 is norm dot CDF function of D1 comma 0 comma 1. So that is between 0 and 1. So this is that minus K e to the power so e to the power minus RT, which is exponential. So NP dot exp, okay, NP dot exp of minus R into T. So minus R into T. So that will give me this part, and that multiplied with ND2. So norm dot CDF of D2 0 comma 1. So S ND1, this is ND1 minus K e to the power minus RT into norm this one. So this is my call price. So put it here. So the call price is equal to this. So see the call price. So the call price is, okay, so the call price is 160.719963. So if you go back here and if you see the price here, you can see the LTP 160.70. So which is exactly matching with our calculation. Okay, so our call price is right. Now see our put price. Okay, so the put price is, so if you see the formula here, so the call yield basically the, if you see the logic behind is, so the spot price minus the expiry here, and here the expiry minus the spot price. So the minus will be here. If you see here, so what is going to do, so this part will multiply with minus. So this D2 will be minus. Okay, so K e to the power minus RT to norm minus D2. So this one, okay, minus S0 minus D1, this one. So this is your put price. Okay, so just put price is equal to this. All right, so what is my put price? So before we run the put price, if you remember what I told you, when you are going to calculate the put price here, you have to use the IV of put side. So this 17,750 strike, what is the IV? 15.11 is the IV. So I'm going to change the IV here, so which is 15.11. So this is 15.11. So this is 15.11. So if I run this, and then if you run this, and then if you run this, you can see the price here 81.01. You go back and see here 81.05. So it's exactly matching. So it means our option price calculation, or the equation of these two is done. So we have done with the pricing of call and put with this mathematical equation. All right. So before now we will move to the option Greeks. So let me put all this together, so it will be look nice. So here these two, let me put it here together, and let me delete this, or you can say delete this. So here you can say option price. Okay, cool. So okay, this is done. Now what we need to do, we're going to calculate all the Greeks now. Okay, so first is, as I told you, delta, gamma, vega, theta and rho. All right, so we're going to calculate one by one with this mathematical equation. But what is delta, what is gamma, what is vega, what is theta, I have already told you quickly. And also I have a lot of videos in my channel what exactly is gamma and videos and all kind of thing. So you can just go through all this video. I'm going to put all the link in the description. You can just go through it. So this is, we're going to calculate quickly. Delta, gamma, vega, theta, rho. All right. Okay, so you can just put simply Greeks. Okay, so first is delta. So before that, what I'm going to do now, I'm going to see one calculator here. So this is option value calculator, which is available in the internet, and this is Upstox. So Upstox is a broker which we use generally in India to trade in NSE and BSE as well, to buy stocks, derivatives and all. So I'm not going to use this calculator, but what I'm going to do, we are going to calculate everything here, and we're going to put the parameter here to see whether our result is matching with this or not. If it is matching, it means that our mathematical equation in Python is correct. So just to verify, I'm going to use this one. You can use any of the option value calculator available in the internet. You can use that and you can compare with, or you can recheck with the value. All right. So I'm going to use that one. So let's quickly change the sigma value now. What I'm going to do, I'm not going to change IV each time. I'm just going to put this 8.39 as IV. Assume that that's my IV. So 8.39. You can put your sigma, you can put your time, you can put your R, you can put your K and S as per your calculation and all. So if that is the case, so let's go and start about this calculation of the Greeks through this Python, all the mathematical equation. Okay, all right. So let's see what is a delta and what is the equation of delta. So the call delta is ND1 and the put delta is ND1 minus 1. Okay. So let's go and see what is ND1 and what is ND2. So anyway, so we are going to calculate this. So what is this is my call delta. So the call delta is norm dot CDF D1 0 and 1. Okay, so this is my call delta. So if you see the call delta, and it is 0.6540. Okay, so let's put it here, all the parameters. So I've already put it here. If you can see, underlying price is 17,854 and the strike price is 17,750. Volatility is 8.39, interest rate is 10%, there is no dividend yield here, and expiry is 6. So if you see, the call price here is matching. This is the call delta, so 0.7585. okay, so this is the call 0.7585, and if you see here, I think all right, I think so we have to run it again, because we run it here, right? So we change the sigma, so we have to run it again. So sigma, and then this one, this and this one, and see the call delta 0.75851. okay, see here 0.7585, so it's matching. So our call delta is done. Now what is put delta? So the put delta, if you see here, what is the formula? The put delta is ND1 minus 1. So ND1, this is ND1. okay, so ND1 minus 1. So this is my put delta. okay, so this is my put delta, and see what is the put delta here. So put delta is minus 0.2414. Go back and check, minus 0.2415. So it's exactly matching. So we got call delta and put delta. okay, now let's go to the next Greeks, or you can say put here delta. okay, so what is the next Greek here? So the next Greek is gamma. So what is the formula for gamma? Now n dash d1 divided by s0, then sigma t. okay, so n dash d1, so this n dash is, as I told you, this is your probability density function, not CDF function. So you have to put norm.pdf. okay, so norm.pdf we have to put here for gamma d1. so norm.pdf d1 0 1, okay, that divided by n1 d1 divided by s sigma into square root of t. okay, s sigma square root of t. So s into sigma into np dot sqrt sqrt square root of t. all right, so put it into a bracket. So I got norm pdf d1 divided by s sigma square root of t. So this is your gamma 0.0016. Go back and check 0.0016. Now it's matching. So gamma is same for both call and put. So now this is done. all right, so this is done. Now go to next Greek is Vega. Vega is, so S0 square root of t and d1. So S0 square root of t s into square root of t np dot np dot sq square root of t, okay, into I think so nd1, okay, nd1. So nd1 is anyway this one, okay, this is nd1, this. So if you run this, this is your Vega. So in fact Vega always you have to divide it by 100, okay, 7.1400, go back and see, Vega is 7.14. all right, so it's now matching. So this is my Vega, okay, so this is done, this is done, all right. So this is your gamma and this is your Vega, okay. So this two is also done. Now next let's move to the next one. So the next one is basically your this one, which is your theta, okay. So theta is different from col and put. So this mathematical equation is for col theta and this mathematical equation is for put theta. So we have to calculate quickly. So the col theta is this one and put theta is this one. So let's first start the col theta. So the col theta is equal to minus s nd1 sigma. So minus s into nd1, I think this is nd1 into sigma, okay. So this is s nd1 sigma whole divided by 2 into square root of t. So that divided by 2 into np dot sq or t square root of t, sorry, capital T, okay. So this part is done. Now minus, okay, r x e to the power rt. So this x is actually it's k for us because this is the you can see this one, we have put k here, the variable which is your strike price, okay. So we put it x here, but actually we have taken k. So r minus, so minus r k into k e to the power rt. So minus r k, so minus r into k into np dot exp, okay, to the power minus r into t, okay, into I think into n d2, okay, n d2. So n d2 is this one, norm.pdf n d2, but it's PDF or CDF, we have to check it. So it's CDF. So this is your CDF, okay. So this is CDF. So col theta is always divided by 365. So the col theta divided by 365, what is coming? Minus 8.6583. So we can go and check, minus 8.6584, okay, it's matching. So this is my col theta, okay, col theta is equal to this. All right, so now we can calculate the put theta as well. So the put theta is the same as put theta is the same as put, but here instead of minus d1 d2 it is minus d2, and this would be a plus. So everything else is same here. Okay, so we are going to simply copy this formula, copy here, so put it here. So this is your plus and this is minus d2. Everything else is same, I think so. Let's go and check it again. So minus h0 and d1 sigma this plus and this thing. Okay, so if that is the case, so this is my put theta, this is my put theta is equal to this, and the put theta is, so the put theta is, so the put theta divided by 365 is this minus 3.80. So the put theta is put theta divided by 365, which is minus 3.80. If you go and check here, minus put theta minus 3.80. Okay, so now the put theta is also matching. So we got put theta and col theta here. So we got put theta equal to put theta, oh my god, divided by 365. Okay, 365. So the put theta minus 3.80. So we got the col theta, we got the put theta. Okay, so let's put it together. Okay, and I don't need this one, so let's put it together, this one. So this is your theta. Okay, this is here, this is here. Now next move to, so we got delta gamma vega theta, and now we are going to calculate the last one, which is rho. Okay, so rho is a simply one, k into t. So k into t into k into t. So k into t into t into e to the power rt. So dot np dot exp, okay, minus r into t, okay, that multiplied with your nd2, okay, nd2. So nd2 is norm, done CDF of d2 0 1. Okay, so that is my rho. So that whole divided by 100. Okay, so 2.199. so go and check, 2.199 is your call rho. Similarly, we can see the put rho as well. So the put rho is minus and minus d2. So simply we can say here put rho is minus and minus D2. So I hope this will give the port row 0.7132. So 0.7132. So we have calculated everything. So this is my call row and this is my port row. Okay, so I got call row, I got port row. So let's mix with this one, and I can see here. So this is my row and delete it. So I got delta, gamma, vega, theta and rho. Okay, so this is all about of your Greeks, and this is your option price. I hope you understand the whole concept and mathematical derivation of all this mathematical calculation, and this is how you can calculate all your Greeks. Okay, so also if you can see here, all the Greeks is exactly matching here. So I hope you understand. So if you just want to make it a little bit better presentation of, you can just write down a table where you can see all the data here together. All right, but this is what it is, all the calculation. Okay, I hope you understand these videos, and the intention of making this video is just to understand how you can write down all the code in Python to do option price as well as the option Greeks. I hope you enjoyed these videos. I have noted down all these points here to understand all the Greeks. Also, I have created one more videos of option Greeks only, where you can understand what are the impact of Greeks. All right. So I hope you enjoyed this video. Thank you so much. Thanks a lot for watching this, and hopefully we'll meet soon, and I will bring some new topic to make all these videos and all kind of financial things, and how you can make all these things into Python. All right. Thank you so much for watching this, guys. Thanks.